In this video, we're going to solve exponential and logarithmic equations. So let's take a look at our first example. Before we do that, let's kind of review. Let's say you have 2 to the third power, 2 to the power of 4. Now, recall that that's same thing as 2 to the 12. When you have exponents next to each other, you just need to multiply them. So if you have 2 to the x, 2 to the power of 3, this will be the same thing as 2 to the 3x. So in order to solve these equations, first, the base is different, so we need to have the same base. Let's try to make it in terms of 6. So this will be 6 squared 2 to the power of x plus 1 equals 6 to the x plus 6. And then you have exponents next to each other, so you got to distribute the 2. You get 6 to the 2x plus 2 equals 6 to the x plus 6. Now you have the same base. So in order for these two to be equal to each other, their exponent needs to be equal to each other. So 2x plus 2 equals x plus 6. Solve for x, you get x equals x plus 2 equals 6, which means x is equal to 4. Now you might want to double check your answer by plugging 4 and see if you get the same answer. In this case, you do. Now let's solve this equation over here. You got 1 over 2 to the power of c equals 64 to the power of 1 over 2. You have a different base. But it looks like we could make it in terms of 2. So that becomes 2 to the negative 1, 2 to the power of c, which will be 2 to the negative c. What about 64? 64 is 8 times 8. And you know that 8 is 2 to the third. So basically 64 is the same thing as 2 to the 6th power. So this will be 2 to the 6th power to the 1/2. Multiply 6 and 1 over 2, you get 3. So therefore, in order for these two to be equal to each other, negative c has to equal to 3, which means that c has to be negative 3. So go ahead and check, see if 1 over 2 to the negative 3 is the same thing as square root of 64. Now we're going to solve each logarithmic equation, and they want you to round to the nearest hundredth if necessary. So you got natural log of x equals 6. Now there's 2 ways of solving this. So first, what is natural log? Natural log is log with base e of x equals 6. So in order to solve this, the base is e, and the exponent is 6. That has to equal to x. And that is as far as you could go without the calculator. So if you want to evaluate what e to the 6th power is, you have to use your calculator. And it turns out x is approximately 403.43. Again, you might want to confirm it with your calculator. Now, what is the another way of doing it? Let's say you got natural log of x equals 6. Now remember, natural log of x is the inverse of e. So what we're going to do is we're going to e both sides so that these two become exponents of base e. We call this process to exponentiate. You just exponentiated both sides. So now what happens? E and natural log cancels out. You get x equals e to the 6th, which is the same as the answer we got earlier. So you have 2 different ways of doing it, but I think this second method is easier. So if you have negative 3 natural log of x equals negative 24, in order to solve this, what you need to do is you need to divide both sides by negative 3. So you have natural log of x by itself. And then what do? You exponentiate both sides. So e and natural log cancels out. You get x equals e to the 8. And this is as far as you could go without the calculator. Now let's solve this logarithmic equation. In order to do that, you need to have log by itself. So let's subtract 6 both sides. You get 2 log of 5x equals 12. And you want to get rid of 2 in front of log, so let's divide by 2 both sides. You'll get log of 5x equals 6. Now notice this is a common logarithm. So base is 10. So 10 to the 6th power equals to 5x. What is 10 to the 6th power? That means you're going to have 6 zeros. 1, 2, 3, 4, 5, 6. So it's a million. And then to solve for x, you got to divide by 5. You got to divide both sides by 5. You end up getting 200,000, 200,000. And that is your x. And if you want to check your answer, you want to plug that to the x over here and see if they're both equal to 18. Now we need to solve log base of 8. X cubed equals 12. So this is a logarithmic form. In order to solve for x, we have to change it to exponential form. So base is 8. Exponent is 12. That should equal to x cubed. So how are we going to solve for x? We need to get rid of the power 3. So what we need to do is we need to raise both sides to the power of 1/3. So that 3 will go away. Or you could do cube root both sides, same thing. So now you get 8 to the power of 4, because 12 times 1/3 is 4, equals x. And what is 8 to the 4th power? That's 8 times 8 times 8 times 8, which will be 4,096. And again, you could double check your answer by plugging this value. Plugging this value for x. Okay, now we're going to solve this equation. In order to do this, we have to use a property of logarithms. Remember, there are 3 properties. So here we need to use the product property. So log of base 4 of x will equal to, when you add these, that means you're going to multiply 3 and x minus 2. So log base 4 of 3 times x minus 2, using the product property. So now you have log base 4, log base 4. These two are equal to each other when x is equal to 3 quantity x minus 2. So you end up getting x equals 3x minus 6. Therefore, 2x equals 6, which means that 3 is equal to x. And you could check by plugging 3 for x and see if they're equal to each other. In this case, they are. Okay, how are you going to solve this equation? This is not bad because you have log base 3 and log base 3. Only time when these two are equal to each other is when you have x squared plus 3 is equal to 52. So let's solve for x. You got to subtract 3 both sides. You get x squared equals 49. And in order to solve for x equals, don't forget positive and negative, because this is even. Square root of 49. So you end up getting x equals negative 7, or x equals 7. Now, whenever you had to square root to solve for x, you got to be really careful to check your answer. So plug in negative 7, you get 49 plus 3, which is 52. And plug in positive 7, you also get 52. So these two are both solutions. Now we're going to solve 4 to the x equals 13. Notice the exponent is variable. So how are we going to solve this? Well, this is exponential form. So one way is change it to logarithmic. So log base 4 of 13 is x. Remember, logs are exponents. So now how do you solve this? Do you remember change of base? You can rewrite this as natural log of 13 over natural log of 4. That's one way of solving it. The other way is let's natural log both sides. Okay? We natural log the left, we natural log the right. So now, remember property of natural log? The exponent goes in front of natural log. Now, how do you have x by itself? You got to divide both sides by natural log of 4. Notice you get the same thing. So there are two ways, and I think the second method is easier for me. But you choose. You choose whichever method is more comfortable for you. Now, using your calculator, you know that x is approximately 1.85. Now let's solve e to the power of 4 minus 3x equals 6. Now you could also change it to logarithmic. So log base e of 6 equals 4 minus 3x. And what is log of base e? That's natural log. So natural log of 6 equals 4 minus 3x. And all you got to do is solve for x. So you end up getting natural log of 6 minus 4 equals negative 3x. Divide both sides by negative 3. You get natural log of 6 minus 4 all over negative 3. Now, all you got to do is change that, use your calculator to get the answers in decimals. And you get approximately 0.74. Now be careful when you use your calculator. Make sure to put parentheses around the numerator, or else sometimes you get the wrong answer. Now, what will be the another way? Actually, the faster way of doing it. When you have e, what is the inverse of e? It's natural log. So let's do natural log both sides. So basically, whenever you solve a variable that is exponent, and you have a base, you want to do natural log both sides. So what happens? Natural log and e cancels out because they're inverse. You get 4 minus 3x equals natural log of 6. And you just have to solve for x, which is negative 3x equals natural log of 6 minus 4 divided by both sides by negative 3. And you get the same thing. Now we're done with part 1. And the next part 2, we're going to look at more complicated logarithmic and exponential equations.